Hello, ladies and gentlemen, once again coming to you not quite live from One Take Studios, where today's topic is solving multiplication and division equations. Yes, I have tackled that concept recently. However, today we are putting fractions into the mix because everything is better with fractions. All right, brief recap for solving equations. I've got a couple of questions to focus your mind. If you are solving equations, ask yourself the following questions. Where is the variable? Because if our goal is to get the variable by itself, it'd be nice if we knew where the variable was. And once we have found the variable, what is with the variable? What numbers are around the variable on the same side as the equal sign? Because those are the things that I'm looking at the attachments. So how is each of these things attached to it so that ultimately I can break the attachment? I want to get the variable by itself. I want to find the variable. I want to find the things next to the variable. I want to figure out how they're attached so I can undo those things, so I can break that attachment and I can get x by itself. That is the general game plan for solving all equations, pretty much. And today with fractions, I have one additional thought for you. And that thought is going to be, a fraction is like a combo meal. It's two operations all wrapped up into one. Okay, so if you can kind of think about that, that might help you a little bit. I'm going to go ahead and move this off, and we're going to look at a couple of examples here so that you can see what I mean. So we're keeping these questions in mind. So here's our first example. It's 2/3 x equals 8. 2/3 x equals 8. Where's the variable? Dun, dun, dun. It is right there. What is with the variable? 2/3. Yes, it's a fraction. How is it attached to the variable? Most people would tell you this is 2/3 times x, and quite frankly, most people would be right. However, I would like you to consider something. I would like you to consider this being two operations. This says that I'm multiplying times 2, so it's 2 times x, but I'm dividing by 3. So yes, it's one number, but this is our combo meal, all right? It's two things wrapped up into one. It's a fraction, it's 2/3. That means we're doing times 2 and dividing by 3, two things at once. Because all of a sudden, if this makes sense to me, and if I can view fractions as two different operations, I don't have to memorize any weird stuff for how to multiply and divide fractions and blah, 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 because it should make sense. This too is with the variable. Is it attached? Yes, through multiplication. And how do I break multiplication? I break it with division. So if I want to undo times 2, I will divide by 2, because times 2 divided by 2, that'll undo each other. But if I do that on one side, I want to make sure I do that on the other side. I want to divide by 2 here. So dividing by 2 on both sides, keeping the balance, simply undoing what we see. So this is times 2, divide by 2, breaking that attachment and undoing it. Now looking at the 3. If that's dividing by 3, all right, so the attachment is through division. How do I break that? How do I undo division? I do that with multiplication. So this is divided by 3. I am multiplying by 3 to undo the division. If I multiply the left side by 3, I want to multiply the right side by 3 as well. So this tells me what I've got going on. Yes, I was multiplying times 2/3, but if I see it as both multiplication and division, I undo the multiplication, I undo the division. All right, so we've got 2 divided by 2, that's going to cancel out. I've got 3 divided by 3, that's going to cancel out. There's my x by itself. Brilliant. Equals, well, okay, same thing here. And a lot of people, again, struggle with multiplying fractions. But again, let me ask you something. Can you do each of these things individually? Could you tell me what is 8 times 3? Because 8 times 3 is 24, yes? And then divide it by 2. What's 24 divided by 2? 12. So if you see this as a combo meal, if you see it as two operations wrapped together, sometimes it's easier to think about it that way for multiplication and division than it is to try to just memorize weird steps that don't stick in our brain very well. So I could even do these in reverse order if I wanted to. I could say 8 divided by 2 is 4, times 3 is 12. Either way I get there, but I'm doing both operations, the multiplication and the division. So there we go. That is my answer for that equation. That is 12. That's not so bad, right? I think we can handle that. All right, so we look at our next equation here, next example. I've got negative 3/5 x equals 9. Now, the negative, please understand that the negative could be with the 3. The negative could be with the 5. It can go either place. It doesn't matter. So if you want to keep the negative with the 3, you can. If you want to put the negative with the 5, you can. As long as you don't put it in both places, we'll be fine. So since I've got the negative written to the 3 right now, let's just leave it there. And again, where's the variable? There's my x. What's with the variable? Well, this is negative 3/5, but how is it attached? So let's think about how we can view this attachment. Is this negative 3/5, or am I really looking at a combo meal? Am I looking at two things wrapped into one? This says that I'm doing negative 3 times x, so this is multiplication here, but this says that I'm dividing by 5. How do I undo these operations? I'm trying to break the attachments to make this happen. So let's see here. I need to, well, if this is times negative 3, I want to divide by negative 3 to undo that. So times negative 3, divide by negative 3. It will undo and undo, same thing on both sides. If this was divided by 5, how do I undo divided by 5? Times 5. Break the attachment. Do the inverse operation, undo it. So if I multiply this side by 5, however, I want to make sure that I multiply this side by 5 as well. Sometimes, by the way, we put these things in parentheses, and that's not a bad idea. Show what we got going on here. So we are saying I have 5 divided by 5. Multiplying, dividing, cancel each other out. I've got a negative 3 divided by negative 3. We are dividing those things too, canceling each other out. Hey, look, ta-da! There's my x by itself. Equals. All right, well, 9 times negative 5/3, this seems kind of overwhelming. But we can do this. What's 9 times 5? 45. Do you know what 45 divided by negative 3 is? That might be a little bit big for your brain from some time to time, but that would be, let's see, a positive divided by a negative should be a negative. 45 divided by 3 is 15. Again, I can do this in reverse if I want. What's 9 divided by negative 3? 9 divided by negative 3 is negative 3. Times 5 makes negative 15. Either way, I'm going to get the same exact answer. So use the questions, keep you focused, and understand that fractions aren't as scary as they look like they are at first. They're just a combo meal. Two operations all wrapped together. All right? Ta-da! Thanks. Have fun.